All right, we want to get, according to what we said, that is this y really the solution of this? A cosine 2x, is it the solution of this? That means if it is the solution, left hand side is going to be equal to the right hand side. We have our y to be this. If we could get the squared y, the x squared, and we add it to 4 times y, if we are going to have 0, that means this really satisfies the equation. Find that this is a solution of the ordinary differential equation. So let's check that. Y is equal to a cosine 2x. So the y dx is equal to, using the chain rule. I'm not sure if you're very familiar with it. So you're supposed to have known the chain rule before. But let's, a is a constant, that is out of it. So cosine 2x. You say let's y equals cosine 2x. U equals 2x. So the u, the x, is equal to 2. This is the function of a function rule. The y du is equal to, y is equal to cosine 2x, which is cosine u. Trigonometric differentiation. Cosine u, the differential of cosine u is minus sine u. So the y du is equal to minus sine u. So the y dx is always equal to the y du times du dx, which is equal to the y du minus sine u times du dx, which is 2. So this is minus 2 sine u. What is u? 2x. So the straightforward word becomes minus 2 sine 2x. That is the y dx. That is the first order differential. Do not forget it is the second order we are going to, because this is a second order differential equation of degree 1, ordinary differential equation. So the squared y dx to the second power is equal to, this is equal to a times this minus 2a sine 2x. So 2a minus 2a is a constant, so we take it out of it. Using the quotient rule as we used it here again, you should be having 2 cosine 2x. Just follow the procedure we used here. You will definitely have 2 cosine 2x. Minus 2 times 2, minus 4, and a is there, cosine 2x. So this is the squared y, the x squared. So this is the squared y, the x squared. The squared y, the x squared is equal to minus 4a cosine 2x. So this is up, look at it very well. Minus 4, a cosine 2x is a cosine 2x, that is y, right? So minus 4y. Am I making sense? So if I now said, compare it to what I have here, the squared y, the x squared, the squared y, the x squared, plus this 4y is equal to what? We don't know what the right hand side is, and our left hand side is this. So when we did our calculation, what did we get as the squared y, the x squared? We got minus 4y, right? So let's add it to plus 4y. What is the answer? 0. So left hand side is equal to the right hand side. Hence, y equals a cos 2x is indeed a solution of the squared y, the x squared, plus 4y equals 0. So that's that about that. Now let's just use one more thing to check for this kind of situation. Sorry. Let's use one more thing to check for this kind of situation. We have a complex solution here. Y of x is equal to e raised to power ix. If x is an element of the set of real number, find that the squared y, the x squared plus y is equal to 0. Confirm if this really satisfies this equation. That's what we are asked to do. You know that the y, the x is going to be, I is a complex number, but it can be differentiated, yes. So it can be used in differentiation rather. It's a variable right now. I comes here. That is simply, it's a constant right now, sorry. That is simply using the chain rule again. Chain rule, e raised to power u. So equals to y. dy du equals e raised to power, e raised to power u will still be e raised to power u. So the u dx, because u is equal to ix, the u dx is going to be ordinary I, right? So dy dx is equal to du dx times dy du. What is du dx? I. What is dy du? E raised to power u. What is u? Ix. That is I e raised to power ix. That is my dy dx. I e raised to power ix. So the second derivative now, that is the squared y dx squared. And that is simply differentiating this. I is already a constant out of it. Differentiate e raised to power ix again. That is still going to give you I e raised to power ix using the method we used here, because we did exactly the same thing. This is equal to I squared e raised to power ix. And we told ourselves that I squared, I is equal to square root of minus 1, right? It is a complex number which has the magnitude square root of minus 1. Now, I squared is equal to what? Square root of minus 1 squared. So these are known parameters, but I said we should always show it so you won't be lost in any case. Squared cancels square root, right? We are left with minus 1. That means anywhere I'm meeting I squared in the whole universe, I know it is going to be minus 1 times the e raised to power ix. Hence, the squared y, the x squared is equal to minus e raised to power ix. So let us confirm if that really obeys this. They said the squared y, the x squared, which is minus e raised to power ix, plus y. What is y? E raised to power ix. What is it equal to? Minus e raised to power x plus e raised to power x is equal to what? 0. Hence, it satisfies the equation. You can try to do more of this on your own. If y of x is equal to c e raised to power ix, or yes, c e raised to power x ordinarily, c e raised to power x, fine, then dy dx, okay, dy dx is equal to y. So deduce that this is a solution of this. Thank you.